So I hope you understand what is this instruction queue. Next we are going to see execution unit. In this execution unit we fetched the data. Now the data is coming to this ALU. So ALU means it is a 16-bit register and it can perform arithmetic and logical operations. ALU can perform arithmetic and logical operations. Right? Next one, what is this flags? And before that, what are called operands? So operand means, like suppose this ALU going to perform some operation on something, right? That is called operand. On what? Maybe this unit going to, this ALU unit going to perform addition operation on what and what. For example, 5 and 8 we are going to add, means 5 and 8 are operands. If we are going to subtract 5 from 8, then the 5 and 8 are operands, right? And we will see now what is flag registers. And this flag register also 16-bit long. So remember, all the registers whichever we have in this processor, all are 16-bit registers. Now we will see flags are 16-bit register. It can store 16-bit information. So in this many flags are there, like CY, P, AC, Z, S, T, I, D, O. So CY means carry flag, P means parity flag, AC means auxiliary carry flag, Z means zero flag, S means sign flag, and T means track flag, I means interrupt, D means direction flow, O means overflow. Direction flag and overflow, right? So we'll see one by one all these flags, and from D0 to, this is the starting digit, binary digit, and till D7, what are all the flags we have? These flags are called status flags. And from D8 to D10, these flags we can call it as control flags. Okay. Flag register is a special purpose register. Depending upon the value of results after the arithmetic and logical operations, and flag registers becomes either set or reset. Set means 1, reset means 0. So each and every flags here consists of only 1 bit memory, and it can store either 1 or, sorry, it can show the status either 1 or 0. If it is 1, then the particular flag is set. If it is 0, the particular flag is 0. No, sorry, if it is showing 0, then the particular flag is reset. Okay. After the arithmetic and logical operation, this flag register will get update and it will show the status of the particular. Right. One by one we'll see about this flags. First one, carry flag. If the carry flag is 1, then the carry generated after the arithmetic operation. If the carry flag is 0, then no carry been generated after the arithmetic operation. So we have taken one example. See, in this example we are adding the values. After adding the value, we are getting a carry here. So immediately your carry flag become 1. See here, become 1. So because carry is generated after the arithmetic operation, here we performed a binary addition, right? So after addition we got the carry, so that your carry flag indicating yes, carry been generated after the arithmetic operation. So next example, so here we have taken 8-bit data, 2 8-bit values, and we are performing the addition operation. So after adding, I am not getting any carry. After the addition I am not getting any carry. Here no carry, so that your carry flag indicating there is no carry generated after the arithmetic operation. Right? I hope you understand what is carry flag. So carry flag, if it is 1, then carry is generated. If carry flag indicating 0, then no carry is generated. Now next one is parity flag. So parity flag is used to indicate number of ones in the result. If the number of ones are even number, then it will indicate 1. If the number of ones are in odd number, then it will indicate 0. If the parity flag is set, then we can understand the number of ones in the result is in even number. If it is reset, then we can understand the number of ones in the result is in odd number. This parity flag generally used for error correction and all. So we'll see one example. So see this, here I have taken two 8-bit datas and I performed the addition operation. After adding, how many ones are there in the result? 1, 2, 3, 4 ones are there. So result has 4 ones. 4 is a even number, so that your parity flag indicating 1. Right? Next example. Here also I am performing addition operation and I have taken two 8-bit datas. After performing the addition operation, this is what my result. Just count the number of ones in the result. 1, 2, 3, 4, 5. So I have 5 ones in the result. So 5 is a odd number. 5 is an odd number. So your parity flag indicating the number of ones in the result is in odd number, so that your parity flag reset. Okay, I hope you understand what is parity flag. If the parity flag is set, then the result is having even number of ones. If the parity flag is 0, then it indicates the result is having odd number of ones. Then next flag register is auxiliary carry flag register. So auxiliary carry flag, it is indicating, so carry flag and auxiliary carry, you just compare and can study. See this one example we given. So this is the 8-bit data. This is also 8-bit data. Two 8-bit data we are going to add. Okay. So first I am adding 0 and 1, I am getting 1. Then 1 and 0, I am getting 1. 0, 0, I am getting 0. 1, 0 if you add, you will get 1, 0, right? Sorry, 1, 1 if you add, you will get 1, 0, right? So 0 is the 0 is the value, then remainder will be 1 here. So that is like a carry. After 4 bits, after adding this 4 bits, I am getting the carry. So that carry will be indicated in this auxiliary carry flag. After one nibble, lower nibble, after that lower nibble addition, if any carry comes, then this carry flag will set. If no carry comes, then this carry flag will reset. Okay. What is the difference between carry flag and auxiliary carry flag? Auxiliary carry flag will indicate after the lower nibble if any carry is generated or not. But carry flag will indicate after the entire 8-bit addition, any carry if it generates, then the carry flag will indicate 1 or 0, right? Whether it is carry is generated or not. But auxiliary will indicate after a lower nibble, after the lower 4 bits addition, right? I hope you understand what is auxiliary carry. So see this one, in this addition we are getting carry, so that your auxiliary flag will set. Now it is indicating 1, right? So another example, see in this example, here also we are performing 8-bit addition. But in this example, after the lower nibble, I am not getting any carry, so that your auxiliary carry flag indicating 0. Right? I hope you understand what is the difference between carry flag and auxiliary carry flag, and when the auxiliary carry flag will set and when the auxiliary carry flag will reset. Next one is 0 flag. And this 0 flag will set if the result is 0, this 0 flag will reset if the result is not equal to 0. Now we have taken one example and we perform the addition operation. Here I am getting the result 0 1 0 1 1 0 1 0. This is not 0, this value is not equal to 0, then your 0 flag goes to reset state, because which means it indicates that result is not equal to 0. And one more example. See, in this example we are performing addition operation. Two 8-bit values I have taken and 8-bit addition I am performing here. See, in this I am getting 8 zeros. Okay, anyhow carry we are getting, but result is this 8 zeros, indicating your result is 0, right? So that your carry flag is set. Now your 0 flag is set. 0 flag indicates. Next is sign flag. So sign flag, it indicates whether the number is negative number or positive number. If the number is negative number, then your sign flag will set. If the number is positive number, then your sign flag will reset. So we'll see how it is going to identify whether the number is negative or positive based on most significant bit value. So MSB value. So if the MSB is 1, then it indicates that the number is negative, then your sign flag is showing 1. If the MSB is 0, then it indicating it is a positive number, so your sign flag shows 0. If MSB is 1, sign flag also 1. If MSB is 0, sign flag also 0. So we will see the example, one example. See, here also we are performing 8-bit addition. So after performing this 8-bit addition, MSB is here 1. See here. See here, your MSB is 1. So if MSB is 1, then sign flag also shows 1. So see here, your sign flag shows 1, which means it indicates that the result is negative number. Result is a negative number. We'll see the another case. So see, here also we are performing 8-bit addition. After adding these two 8-bit values, so I am getting the result 0110 0110. Here MSB is 0. So which means this number is positive number. So if MSB is 0, your sign flag also 0. So sign flag shows 0 here. So which means it indicates that the result is positive number. So I hope you understand what is the sign flag and when it is set and when it is reset. So far we discussed some of the flags, which are they: carry flag, parity flag, auxiliary carry, zero and sign flags. So these flags are called status flags. So for 5 flags we discussed, those 5 flags are called status flags. Now we are going to discuss control flags. So we'll see. So first flag name is trap flag. So this trap flag, if the trap flag value is 1, then your processor is working in single step mode, which means, see here we have taken one ALP program. So we are moving 25 to AL and 35 to BL, then finally we add AL and BL and result will be stored in AL. Then halt. This is what the program, addition program, simple addition program. If the trap flag is 1, then the processor will work in single step mode. See here, in each and every instruction it will check. It will check. After executing each and every instruction, it will check whether any error is there or not. So that kind of mode is called single step mode. Okay, I hope you understand what is single step mode. So each and every step execution, it will check whether any error is coming or not. Like that it will check. Okay. So another case, suppose if your trap flag is reset, that means 0, then it will execute the entire program, then finally it will check whether any error is there or not. So this single step mode will be used for debugging purpose. So I hope you understand what is trap flag. If it is reset, then it will show 0. If it's set, then it will show 1. If it 1, if your trap flag is 1, then it is working in single step mode. If trap flag is 0, then it will execute all the instructions, then finally it will inspect the probe. That's it. So that is the difference between single step mode and the another mode. Next one, I flag, which means interrupt flag. So interrupt flag will be set, that is 1, when the microprocessor will recognize interrupt request is coming from the peripherals. If the interrupt flag is reset, that is 0, that time your processor will not recognize any interrupt request and it will ignore them. So if the processor recognize interrupt request, then your interrupt flag is 1. If the processor not recognizing and ignoring, then your interrupt flag shows 0. I hope you understand the set and reset states of interrupt flag. So next one is direction flag. This direction flag particularly used in string operations. String operations like string instructions, right? String instructions in the sense, suppose if I am going to fetch a group of bytes, start from here to here. If I wanted to fetch, then the pointer should start from this value, then it should increment here, 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 like that, right? Or if I start from here, then it has to go downwards. So pointer either goes upward, or in some cases the pointer should go downwards. So particularly in push and pop operations, that time and all, based on this direction flag, it will decide the direction, whether it should increment or decrement, right? So in that cases, this direction flag is specially used. So specifically that is used in the string operations. So see here, if your direction flag is 0, then access the string data from lower memory location towards higher memory location. And if the direction flag is 1, then you are going to access the string data from higher memory location towards lower memory location. So if the DF is 0, then incrementing. If the DF is 1, then decrementing. I hope you understand the set and reset set and reset status of direction flag. See, 1 and 0. If it is 1, then it is the direction flow is from lower to higher. If the DF is 0, then the direction is lower to higher. If the DF is 1, then the direction is higher to lower. The last one is overflow flag. So this overflow flag is indicating whether the answer is wrong or not. Suppose see here, when we are adding these two values, so we are getting 1000.
But actually, see, first number and second number, you just see both the numbers MSB value is positive and output also should be positive, but by seeing this MSB we feel like it is a negative number. So that time your overflow flag indicate that its answer is wrong, like that. Next case, here both are negative numbers you are adding, then final output should be a negative number, right? Because both are negative numbers. Then your result also should be here. By seeing MSB we have 0, right? So if MSB is 0 in signed number additions, we are considering this is a positive number. Here also it is not a positive. Actually, in signed number addition, it is also, the result also be a negative number, right? So that time overflow flag shows error in the answer. So like that, see, wherever it is coming properly, see here, this is positive, here also positive, so your overflow flag turn off. And here 0, which means this is positive number, here negative number. So one positive number, one negative number, we are getting negative number. Here also overflow flag shows, it shows 0 only. Then here it is negative number, here positive number, again negative. In this case also overflow flag turned off. Here negative means result should be negative. Here also your overflow flag turned off. If you are doing unsigned arithmetic, then overflow flag means nothing, should be ignored. So only overflow flag used in the signed addition or subtraction or whatever. Signed arithmetic we will consider overflow flag. So thank you. We will see further topics in the next class.